In this world, there's no IPs and ports anymore. There's services and identities, and that's it. Like, you don't even care about the IPs anymore because the only entities talking to your systems are the trusted identities that you've explicitly granted access to.
This is DevOps Paradox, episode number 158, Powering Zero Trust with OpenZD. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick.
When we talk security, we think passwords or firewall rules or those kinds of things. Right, Victor? These are just normal things.
No, my first thought about security is how much I dislike guys working in security in my company. They're preventing me going live.
Yeah. And today we've got a guest on with us. We've got Mike Guthrie on from NetFoundry. Mike, how you doing today?
I'm doing great. Thank you guys for having me today.
Yeah. So, Mike, why don't you introduce yourself a little bit more, explain what NetFoundry does, and why we're starting to talk about security and why it doesn't necessarily have to be painful.
I'm Mike Guthrie. I lead our DevOps team at NetFoundry, and NetFoundry provides a zero trust networking solution as an infrastructure as service, and it's powered by an underlying open source technology that we're developing called OpenZD. And what we provide as an enterprise layer on top of that is all orchestrated so that people can click a few buttons and stand up a network and so forth and have a friendly UI and so forth. But it is powered by an open source technology underneath to make it all work, which is free and available for people to try as well.
How is it licensed, by the way?
I want to say it's the Apache license, if I remember correctly.
Okay.
But
we can look later, but it was just
yep.
I forgot to do my research on that, so I apologize. So, what is zero trust?
Zero trust is, particularly in a networking space, it's the idea that we want to get away from, at least as we're looking at it and trying to define it as NetFoundry, because it's getting a little bit overused in the industry right now. But think of it in terms of, you put authentication in front of your application, but we don't do the same thing as far as the networking layer. We'll have, an IP or a port open, just serving some sort of traffic and so forth. And oftentimes anybody can hit that IP and port. Once they hit that, they still might have a login and so forth. But whatever is serving behind that IP and port is still subject to whatever vulnerabilities that application might have and so forth. It's still subject to DDoS attacks and things like that. And so zero trust is basically, it's introducing a layer of trust at the network layer. So it's saying nothing can even talk on this IP and port unless it is explicitly granted trust. And it's granted trust to a given identity. So, and it's a kind of a device level identity. So my cell phone is an identity. My laptop is an identity. I can also have, with OpenZD, you can actually do fully embedded application where the application itself is an identity, and the encryption actually begins from inside the application, so you never have unencrypted traffic and so forth. So it's creating a new layer of security just around your what would typically be open ports and open IP addresses. And I think the other thing that is just interesting and unique about it, that really I think gives the most strength as a layer of security, is that everything works by essentially dialing outbound into a central mesh. And as a result, you can have your firewall rules start with basically a deny all policy where nothing can get in, and you can actually leave it that way. And because everything dials outward to establish the connection to the mesh, it's the ZD fabric itself that's actually controlling what to talk to what.
So what are some of the typical use cases that you're seeing today for these types of apps?
The place that we wanted to start, at least for us internally, we wanted to start kind of dogfooding our own product. We started initially by using an internal chat platform. We moved away from Slack and we moved towards Mattermost to kind of just as a way to exercise it, to where we can only get to our internal communications platform by using ZD. Basically, what we just say is everything's dark. You can't get to it. But then we wanted to try to find more use cases. And leading DevOps, we have a lot of internal tools that, connect systems and are in charge of deployment, but there are a lot of sensitive systems that we didn't want open to the world. And the first one that I started looking at was actually our data warehouse, to where we needed our team members to be able to access it, from their laptops, from anywhere and so forth. But the IP, it was protected with credentials, but the IP and port was still open to the world. And this continually just made me more and more nervous with time as we started to put more and more in there. So I'm like, all right, let's try putting this behind ZD. And so we made the decision to what we say making it dark, to where there's no public access to it anymore. And you can only get to it through ZD and through granted trust through ZD. And so that was the first implementation that we did. And I know for me, coming from more of an ops background and a developer background, much, kind of as you guys mentioned at the beginning of this, to where when you think security, you're like, it means, painful headaches. It means adding frustration and annoyance to existing processes and making things harder for us to use and so forth. And what I found is that when we switched over to it, we were able to kind of get everybody enrolled with the Zero Trust Network. And when they started using, we were actually able to pre-validate all the changes, to where it said, okay, everybody, put this client on your laptops to access it, test all the accessibility, make sure it's working. And with NetFoundry's implementation of ZD, we can actually see, with the various metrics that we collect, we can actually see who's accessing what services at any given time. And so we for every byte of traffic that flows over the fabric, we know which identity it was, we know which service they were accessing and so forth. We started with the data warehouse, and before we ever locked it down, we made sure everybody was able to access and we could see all their traffic flowing. So then on the day when we locked it down and revoked the public access, I was fully expecting fireworks, because that's been my experience every time, we lock down anything in security and increase the access controls and things like that. And it ended up being this complete non-event, because we'd already done all the pre-validation ahead of time. And we knew all the users who needed to access it already could. And so the day that we went dark with it, we're like, I guess that's it. And we're done. And that was actually so much easier than I was expecting it to be. And we didn't even break anything. Cool, let's go do another one. And that kind of started our journey with figuring out where we could apply it.
What are the users of ZD or NetFoundry replacing in their stack? Would it be a replacement of VPNs, for example?
A lot of places that we are gaining traction and creating replacements for is VPNs. A key thing that we have over VPN is, one, the general feedback we get from everybody is they're a real pain in the butt to maintain, but also with the VPN, you're essentially letting somebody onto your entire network. Whereas with ZD, you get very, very explicit in terms of who can access what. And so even when you give them an enrollment with their identity and they enroll, they still don't have access to anything yet, except for what you explicitly grant them. And so if you do have some sort of a private service that you need to grant access to, say, an outside user, you can grant them access to just that one thing instead of the entire network. It's very much following the practice of least privilege at the networking layer, to where, okay, they're enrolled and so forth, but they still have absolutely nothing except for their explicit grants. And then that way you can get a lot more specific about what you give access to. And the other thing that's nice too is that with kind of the traffic visibility that we have, is that you also have the accountability too. So you grant them access and so forth, and then you can actually have accountability and see, I can see when they were accessing it and how much traffic they're passing over the service as well. And it solves kind of an accountability problem that I found to be traditionally very, very painful in the security space, to where I used to work a lot I still work a lot in monitoring and site reliability and so forth. And when you get that question from the security team of like, hey, we think, something may have happened, can we see who's been accessing this recently? Usually that's a really, really painful question to answer. And it's actually been made very, very easy with ZD, because we can see all the traffic and who it came from and when they're accessing it and so forth. So it helps a lot with that accountability question as well.
And I'm guessing that the client you mentioned is not, unlike VPNs, it is not really creating a network for everything you use, right? If I Google something, I'm still kind of like on my own network,
Yep.
right?
Correct. Yeah, exactly. So it's not bogging down the rest of your connection either. And essentially the way it works is that if you have a tunneler running on your device, we've got desktop clients, we've got mobile clients and so forth, but that tunneler is just kind of watching and looking for, are there any services that it's supposed to intercept? And it could be an IP address or it could be a DNS name. If you access one of those services that it is supposed to intercept, instead of going to the normal address, it will get picked up by Z and routed through the fabric instead. You can actually, use, legitimate URLs and things like that, but you can also use completely made up URLs if you want to even mask your actual destination address. We'll use a lot of times, we'll use like test.database.zd or whatever, and it's a completely made up URL, but that's actually what you can use as your functional URL for your clients. And they don't know where it's actually going, but they just know that it gets them there.
In that case, to where you're using something that looks like a domain name, but it's really not, I'm assuming there's no DNS entry for it. It's the fabric that's translating that name and knowing where to route it.
Yep, it essentially kind of taps into kind of the some of the DNS interactions on the environment that it's in. So when that DNS lookup occurs, it kind of does first a lookup internally with ZD, and it's like, oh, is this something I'm supposed to pick up and intercept? And if it does, then it intercepts that traffic and routes through.
So it's sort of like a VPN client, but maybe on steroids.
Yeah, I would say in the same way that the way that like AWS implemented, say, IAM permissions, to where you could get really, really explicit about who could access what. Think of it's that level of control applied to networking. That's at least the way that I kind of think of it in terms of a leap forward, in terms of the generational step that it is.
You were saying, okay, I have to add this specific person or this specific, not even person, but this device.
Yep.
Is that the only way you can configure it? Because that seems like a lot of overhead versus I want to grant this to everybody except for. So can you do exclusionary provisioning of access as well?
It is set up to be inclusive currently, but as far as like larger customers, we have things for like Active Directory integration where access is granted through attribute-based access. And so essentially think of it like tagging. So users with certain tags would potentially have access granted to certain things. So for like our larger customers where they have thousands of users, they actually sync it to Active Directory, and then they use potentially their Active Directory group names as those attributes. And they use that to basically bulk manage who has access to what and so forth. The larger thing that actually manages access, at NetFoundry, we refer to them as AppWANs. In OpenZD, they're referred to as service policies. And it's basically just saying, users with this attribute can talk to services with this attribute. And so typically they'll set up the AppWANs and the policies with, whatever attributes they want to create the connectivity, and then they'll just dial it into Active Directory and use the attributes as part of their group names and so forth. And those group names will sync into their identities and so forth. Once they get their invite and so forth, there's a regular sync that will keep their groups in sync and so forth. And they're basically using that to kind of automate the access control. And that's part of the enterprise product. You don't necessarily get that natively with OpenZD because everything's still API driven. If you're using the open source product, I know there are people who are, they're building various different layers of automation and so forth to kind of do the same thing. But yeah, so everything's kind of controlled by attributes. So
that's one thing you've called out, a little bit of difference between obviously the open source project and your enterprise offering. Mm-hmm. With the enterprise offering, do I have to use the UI? Or could I drive it all through API too?
You can do it entirely through API. There's one customer that kind of saw the product and so forth, saw our API, and actually they treat the UI basically as like a read-only dashboard. And they do everything basically automated through pipeline and so forth, and version-controlled configs and so forth, because we have the ability to say, create resources based on like an uploaded YAML and so forth. And so they actually even have their entire network configuration version controlled and pipelined, so that users are never clicking in the console to make changes. It's entirely managed and automated and so forth. And they basically even locked out the permissions so that most users just have read access to the console.
You just made Victor very happy in saying that.
Yep. And for me, I can appreciate that as well, because we rely on Terraform very heavily for all of our AWS stuff too, and it's kind of a big no-no for people to go around clicking stuff and creating things without having it be managed and version controlled and things like that too, because then we don't know how to go back and fix it, or what somebody did to actually make something work, and so it very much the same principle, where it's just like have accountability in terms of what the configuration state should be and so forth.
So you started out dropping Slack, moving to Mattermost. I'm assuming you were self-hosting Mattermost inside your four walls.
Yep.
When you start out, it's a deny all, which is where we all should start. You add the devices inclusively. What happens when the person logs into the client, then that device, that identity is now registered? How does that work? Because if I'm like most of us today, I've got a laptop, I've got a phone, and the apps are supporting that, or at least the network access for those apps are supported. Is that just does it go back? We'll use the Active Directory example.
Yep.
Just that group tagging, is that all that matters? And the devices automatically, once I log in to that, I'll call it the Fabric client, the ZD client, that's it? I mean, it's magical at that point?
More or less. So when you create an identity, you basically issue them an enrollment. They do have to enroll. And the way that we're using it internally for, say, something like Mattermost is like we get a new hire that comes on board. It's just part of our onboarding process. They get an enrollment for their laptop. They get an enrollment for their phone. If they have additional devices, they just request that and say, hey, I've got 2 additional laptops I use for testing, and we'll issue enrollment tokens for those as well. We basically just give them the attribute or attributes that they need upon, as part of their onboarding and so forth. And so as soon as they enroll and they fire up the tunneler, they will have access to whatever services they need at that point.
So that's great for onboarding, but what about lost devices or offboarding?
For lost devices, you do have to reissue a new enrollment token at that point.
Right. But if I lost the device, how do you, as the ZD administrator, deal with now that orphaned approval?
No, that's actually a great question, because that's one of the things that we're trying to figure out how to make that smoother. Because apart from somebody notifying, hey, this identity's dead and so forth, you can remove it. That's a piece that we're still looking at trying to improve and polish a little bit. For people who are using like the Active Directory sync and it's managed, it will that's an option to say just automatically prune and clean that and so forth. But yeah, for lost devices, there isn't a great automated cleanup option for that yet. That's an area that we're running into and still trying to address and figure out how to make that better.
And I like the word that you're using, tunneler. You don't have a tunnel. I'm assuming you have a persistent tunnel, but only for those specific applications. Is that true or not true, or how does that work?
Yeah, it's essentially ready and available for the services that it's going to intercept for. And so and then when you try to access any of those services, it basically creates, we'll call it a circuit, where it will create the end-to-end connection for you and so forth to establish the connection to whatever the thing is on the other side of the fabric. And so it's kind of standing at the ready to intercept your traffic, and then it routes through and so forth when it does come time to access.
That story reminds me a lot on, basically, am I wrong if I say that it's similar to what service mesh would do within a cluster, but applied to everything or outside in a way, right?
I've done a little bit of research on service mesh. I don't know if I would be able to answer in detail how well it compares or kind of feature differences and so forth. There's some of the stuff that I've looked at in Kubernetes space and so forth to where, I forget some of the, they've got like Weave and a couple of the others where it's basically, it's kind of you're defining those service policies and so forth in terms of, what can talk to what within the cluster and things like that. It's a little bit like that, but it lets you apply it kind of global scale to where it's like it applies to kind of really anything that you want to wire up and connect and so forth.
I mean, thinking through this, I can't think of a logical reason to use just a VPN client anymore.
To me, this is very, very kind of a next generation way to do this type of connectivity. There are a few customers that have used it and were using VPNs, and in one guy's words, he was very blunt, and I loved his rawness. He was just like, "Oh, it's just hell to manage," and so forth. And he switched over, and he's like, he described it as magic because it was just like, "Yep, we don't have to monkey around with this anymore. Where it just things can dial in and they can talk and so forth." And he was using it for configuration management purposes, where they had a vended appliance that they would give out to customers and so forth, and it would be deployed in remote locations. But they still had to do configuration management. They still had to do upgrades and things like that for those remote appliances, and they needed a way to centrally manage it. Well, doing that with traditional networking tools is really painful, because for every customer, you got to figure out some way of connectivity to get into their private network space and whatever else, and it's painful, and nobody's having a good time because, of course, you're like, oh, okay, you got to let somebody in from the outside to, have elevated access on a machine, and everybody's has great concern about it, to where this is, they don't have to open any firewall rules, they don't have to set up any VPNs and so forth. The appliance gets deployed with a tunneler, and they simply enroll the tunneler when they fire up the appliance, and that's the end of it. That customer is able to do all essential management that they needed to do from one place, and they didn't have to worry about working with customers to set up those VPN tunnels anymore. And for them, it was a huge win because it just saved them tons of time.
I haven't used OpenZD yet, so I don't know whether it's good or bad and stuff like that, but I'm yet to find somebody who is happy with VPN. So kind of
That's the general sentiment I would say as well. And for me, I've joked with a few people about this where I'm not a sales guy, and usually I'm not like this, big drinker of Kool-Aid or this or that or whatever for whatever, but I'm a problem solver, and I get excited about technologies that I can kind of adopt as like a Swiss Army knife that lets me get a lot of stuff done. And being a DevOps guy, a key thing that we do is we connect stuff together. And we're often like the problem children as far as the security team is concerned, because of course we have access to everything, and we have to connect systems, and everything that we're doing requires us to connect to our most critical production systems, and everything from config management to deployment to monitoring and so forth. And as we started to kind of adopt ZD internally, we're realizing, we're like, man, this is like every DevOps person should be using this, because this is a great way to produce that connectivity amongst your systems, and you never have to create a panic as far as the security team is concerned, because you're never opening any firewall rules anymore. Everything is still deny all. If I need this data center to talk to something in this data center to talk to this data center, not only do I don't have to open any doors between them, but I can still maintain least privilege to where only this one thing can talk to this one thing over here. And it's just a better way to connect things, instead of, VPC peering or BGP peering, things like that, to where you have to create a bridge and open up entire data centers to each other. It's been actually tremendously helpful in just getting stuff done internally. And so now we're just using it as kind of our standard way when we have a new tool that we need to spin up that's kind of in that DevOps space, to where we're using it for internal management. There's with a tool like this, there's not a good reason to open up something like your monitoring server to the world. There's not a good reason to open up your CI/CD server to the world, because you can basically keep it completely dark, and then you only grant access to your employees, through ZD using Zero Trust and so forth. It's been great for us, because it just gives us kind of an extra layer of comfort and so forth, that it's like, yeah, the public can't even get to these resources. You can't get to them without being enrolled and so forth. And also everybody who is enrolled, we know who's accessing it and who isn't. And so it's been a tremendous leap for us forward in terms of being able to connect stuff together and grant access to what I would describe as sensitive systems that we want to have really limited access to. It's been a huge step forward for us in terms of our own security model that we use.
Does it work also? All of the examples that you mentioned are kind of world-facing, right, in a way. Mm-hmm. Does it work also internally? So, like that monitoring tool that you mentioned, and let's say that Mattermost that you mentioned, mm-hmm. maybe Mattermost would, I don't know, get the results from the monitoring tool and show it in your chat. I'm inventing a use case. Would you then use OpenZD also for that internal communication, mm-hmm. or only external facing?
Yeah, and it depends on where it's coming from, but there are certain places where we're doing basically a fully app-embedded type of integration, to where inside the application we're using ZD to actually send stuff to Mattermost and so forth. That kind of app-embedded model is actually something that we're trying to push right now, because that is even yet another generation improved, to where there is basically no real possibility of intercept, because when you do actually an app embedded implementation, SSL's, terminating, or it's encrypting inside of your app, and it terminates inside of the other application, to where there's no way ever you could have unencrypted traffic that is intercepted and so forth. And that's kind of the model that we're trying to promote and kind of teach the industry on, is like, no, this is true Zero Trust, to where you never have a point of traffic being unencrypted. And it's tunneling the entire way, and it starts and finishes inside of the applications. And that for us is true Zero Trust at that point. But it's a completely new way of thinking about security, and because it's such a shift from traditional networking, it's taking time for people to kind of understand the idea that in this world there's no IPs and ports anymore. There's services and identities, and that's it. Like, you don't even care about the IPs anymore, because the only entities talking to your systems are the trusted identities that you've explicitly granted access to.
I'm really happy that you mentioned IPs, because that's one of the biggest pains. I mean, people are contacting me all the time with questions like, okay, so you have a cluster with 3 nodes, and tomorrow AWS is going to destroy that node and create a new one. How do I whitelist? Perfect. You cannot whitelist.
No, I mean, that's the problem, is that that whitelisting idea was fine 10, 15 years ago, but it's like now everything's ephemeral. Or you got an end user that needs to access your system from a coffee shop or something, you know what I mean? And the whitelisting model is it doesn't keep up with where the world is going, and that's why using this new model is so much more powerful. To where it's like, yeah, you don't have to worry about that anymore. It's just like, nope, this is Mike's laptop. We know this is Mike's laptop because it's a trusted entity. If Mike's laptop gets stolen, well, we simply revoke the identity, we delete it, and well, it's not a risk of compromise anymore because we've revoked that identity.
It could also be, I'm guessing, I don't know whether in practice or theory, it could be also, we know that this is Mike without the part laptop, right? And then if Mike happens to work on a different machine, then it's still Mike, right? It's
device specific, typically, or at least as a best practice. Yeah, you could. I think theoretically you could reuse in an enrollment, but I would describe that as a bad practice, to where it's like, no, you want an enrollment per device and so forth. So that way, if, like I said, if that device ever gets compromised, it's very black and white. It's like, nope, we simply revoke that, and that's the end of it.
Let me ask a couple of questions, because you and Victor have been going for a while, and I have a long list now. I want to go back to the app embedded thing.
Yeah.
We were just talking about identities being mapped to devices or devices. But from app embedded, there is no device. Or is there?
The application itself becomes an identity. In the OpenZD world, things that can connect, basically everything's an identity. And whether it's a laptop, a cell phone, a server, or an application, they're all identities.
Okay. That makes sense.
Yeah.
So how does that identity, does that application get an invite? That's where I'm sort of, because it makes sense if I've got a device, I get an invite, I click on it and do the things. But an application, that doesn't make a whole lot of sense.
An application does need to, in terms of the enrollment, there is an enrollment that does need to occur. In terms of how that is stood up in an application, I haven't worked as much with that. There's a couple of devs that have actually done various app embedded implementations. How they handle that enrollment process, I haven't done it myself yet. It's on my to-do still, but essentially once you create an enrollment token, you can use that. And so you could actually use just a like a tunneler binary and say, hey, ZD Edge tunnel enroll, and then you have that enrollment token and so forth. And then that enrollment token is good and could be adopted as part of your application as like an application secret.
Okay, that makes total sense. I want to go back to the appliance scenario that you talked about too. Mm-hmm. When you were talking about poking holes in the firewall, I'm assuming you meant inbound, that you didn't have to poke anything inbound because you were doing centralized management. Mm-hmm. But what if that appliance is setting in a firewalled off, so no egress? Obviously, they've got to poke something outbound, right, in order to establish that connection.
Yep.
Because air gap, that won't work in an air gap. I mean, air gap is air gap.
Yep.
There is no network.
Yep.
I figured that was the basics.
Yep. And we've built the outbound dial on standard ports. I believe we do over 443 just because it's such a common port that is typically always open. If somebody does have everything dark in the outbound as well, they will have to open an outbound port. But yeah, we try to use common ports on purpose. It is configurable in terms of what port you're using. Especially with OpenZD, you could set it up however you wanted. But with NetFoundry, we purposely set it up using common ports so that most people don't have to open an additional outbound port.
I mean, Zero Trust is gaining lots of just mind share right now. Obviously, Google's gone way deep into it in GCP. Mm-hmm. I don't think the other two have, at least if they've been doing it, they're not preaching it as loud as GCP is. Cloudflare is pushing Zero Trust big time right now. Why would somebody not want to use Zero Trust?
I think in this day and age, I don't have a great reason as to why they wouldn't. I mean, it'd be the same thing of saying, why wouldn't somebody want to do least privilege? The only reason at the end of the day is, well, they might not realize they can do it in a way that isn't difficult. I think the assumption is that, and a lot of us have had this experience. It's like, well, in order to elevate your security, you're creating a lot of headaches for yourself. You're making things harder, and things become more difficult to manage. But if you're using the right technologies, it doesn't have to be that way. And, like I said, as we've started to adopt ZD internally, we realize we're like, this actually isn't hard. It's not really any harder than just simply standing up the infrastructure. We just simply stand it up from day one using that, and then it's not hard. I think the barrier for a lot of people in terms of elevating security is thinking it needs to be difficult, but it's if you can do it once, you can model it and continue to move forward with it. And this is a technology that tries to make it easy in the way that turning on infrastructure is easy in AWS. we're trying to do the same thing in the networking space, where it's like, oh, you need your zero trust connectivity to be easy. Here, click some buttons and connect some stuff together, and like that's it, you're done. And so we're trying to remove that difficulty barrier for people, so that security doesn't become this swear word that makes everybody's jobs hard.
For those of us that have things running inside of our home networks, right? I've got a couple of Jenkins servers. I've got other things. This seems like a great way to do it, because typically I would do something like ngrok, get a tunnel, and then do those kinds of things. But that starts to fall apart. Using ZD, or OpenZD at least, sounds like an answer for that, to where I'm not having to, like you were saying before, I don't want to poke a hole in my home router to allow traffic in, especially in these times.
For example, if you had a ZD network already running and you wanted to grant me access to Jenkins, let's assume that your laptop inside of your home network had the tunneler running on it already. You can actually have your laptop be the host and basically be the point of termination of the fabric. So you could say, oh yeah, go from my laptop to Jenkins, and then I want to grant Mike access, and I could access your Jenkins if you granted that to me. You say, hey, help me debug this. And you could give me access and so forth. And so any tunneler can also host a service. It can basically be a point of egress for the fabric, which is pretty slick.
So if people wanted to take a look at this, obviously they can take a look at OpenZD. It's hosted on GitHub, if I remember correctly.
Yep.
Right? And it's what's the site for OpenZD?
I believe it's openzd.org. So I should probably know that off the top of my head, but yeah.
That's fine. Now,
yeah.
Did NetFoundry open source OpenZD, or what's sort of the history around all this?
Yeah, so we started work on it a couple of years ago, because initially when NetFoundry launched, we were using a licensed technology, but the plan was ultimately, it was always to kind of have our own technology, so that kind of our destiny was in our own hands. So we'd started the work on this, I want to say probably 3 years ago. And so it started as kind of a zero trust software edge and so forth, but it kind of evolved into OpenZD. And I want to say at this point it was, probably year and a half ago, we decided to really just go all in towards ZD and really to basically set our future to where our enterprise product was all in with ZD and going to use that exclusively going forward. So we've just about deprecated everything using the former licensed technology and so forth, and and so now at this point, everything going forward is going to be using that. At first, it was a little bit scary because it was new, and we had a lot of learnings that we had to do with it as well. To where me being kind of in like the site reliability and DevOps space and things like that, there was a lot in terms of, because I worked a lot with the metrics and the visibility and the logging and things like that, and kind of doing that in a centralized way. And so there was a lot that we had to learn just in terms of like what was the behavior of the technology and where did we hit bottlenecks and things like that, and it was cool to be on the ground floor of that, to just everybody get on calls, we work through it together and so forth, and grow and evolve the product. But yeah, so it's definitely been a journey, but it's been fun to see where it's gone, and it continues to be exciting to see where it goes as the product evolves and it gets even better with time.
All of Mike's information will be down in the show notes. Mike, thanks for joining us today.
Thanks for having me. It was a good time.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.